We all know the final Apollo lunar landing mission was Apollo 17, but what if it hadn't been? What if NASA had had funding to not only see Apollo through to Apollo 20, but also fulfill its post-Apollo goals? We're doing a bit of a thought experiment today on Vintage Space. In July of 1960, there were many within NASA already looking beyond the immediate Mercury program, looking at long-duration lunar missions, orbital space stations, and even manned missions to other planets. Fast forward less than a year, and President Kennedy promises the nation a manned landing on the moon by the end of the decade. In the years that follow, the Apollo hardware and missions start to take shape, and there were already lofty plans being made to push that hardware beyond the immediate goal of the moon landing, to fulfill these goals of space stations and manned missions to other planets and long-duration moon missions, including building a base on the moon. So why didn't we see any of this happen? And more interestingly, what did we miss out on? Well, there are a couple of ways to look at this question. And because it's all within the umbrella of the Apollo program, more or less, we have to look at them sort of in tandem. So the two sides are the canceled Apollo lunar landing missions and the canceled plans to push that hardware beyond the Apollo program. So let's start with the unrealized lunar landing missions. But first, let's backtrack just a little bit. Apollo took shape in the background as Mercury and Gemini solved all kinds of problems of living and working in space, and so too did the outline of how the missions would proceed. They were all given a letter to denote the mission type. A missions were unmanned Saturn V and Command Service Module flights. B missions were unmanned Lunar Module flights. C missions were manned Command Service Module evaluation flights in Earth orbit. D missions were manned Command Service Module and Lunar Module development flights in low Earth orbit. E missions would be manned CSM and LM tests on a simulated lunar mission. This would see the spacecraft flying in a highly elliptical orbit around the Earth, hitting a peak apogee of 3,500 nautical miles. F missions would be the dress rehearsal before a manned lunar landing. The G mission would be the first attempted lunar landing. H missions would be longer duration stays on the moon, up to 2 days with 2 EVAs. I missions would be long-duration, Command Service Module-only lunar orbital missions designed to survey the moon up close. And finally, J missions would be longer 3-day stays on the moon with an extended lunar module, 3 EVAs, and a lunar rover. So a lot of those mission types should sound more or less familiar, but as we know, that original plan sort of fell apart. There was never an E mission, and when it turned out that the lunar module was falling behind schedule compared to the command module, Apollo 8 became a sort of C prime mission, going to the moon with the command service module only. But still, even when Apollo 8 was flying, NASA was planning to go to the moon through Apollo 20. Well, these missions were never completely planned out to the last detail, and no crews were ever formally assigned to these last 3 flights. But based on what work was done to plan these missions and regular flight rotations, we can get a bit of a glimpse into what these missions might have looked like. Apollo 12's Dick Gordon might have commanded Vance Brand as the command module pilot and Jack Schmitt as the lunar module pilot on Apollo 18's mission to Copernicus. Commander Fred Hayes would have led CMP Bill Pogue and LMP Jerry Carr to a landing at Hadley Rill. And rounding out Apollo, Pete Conrad might have commanded his second crew to land on the moon, with Paul Weitz as the command module pilot and Jack Lousma as the lunar module pilot, landing at Tycho. But maybe not. There's also some speculation that since it would have been Conrad's second landing mission, Stu Roosa, Apollo 14 CMP, might have been given that coveted commander spot on the final Apollo landing mission. But this fell apart pretty quickly after Apollo 11 landed on the moon in 1969. Apollo 20 was the first to go. This mission was cancelled in January of 1970, so before Apollo 13's near disaster in space, but already when NASA was feeling stricter budget constraints on the program. Next to go were Apollos 15 and 19. Apollo 15 was originally on the books as an I mission, but NASA realized it could fold those goals into a J mission, and so it cancelled the last 2 J missions and updated Apollo 15 to be a J mission. So changing goals and dwindling budgets killed the last 3 Apollo missions that would have put more emphasis on understanding the geology of the moon. But it wasn't the only casualty of NASA's dwindling budget as the decade wore to an end. The other thing to go was the Apollo Applications program that started life as the Apollo Extension Series. In April of 1964, the Apollo Logistics Support System Office was established to look at ways Apollo technology could support post-moon landing goals. Broadly, the office looked at using Apollo hardware for unmanned missions, for the first steps towards a space station, and to lay the groundwork for long-duration lunar missions. By 1965, these distant goals were formally on NASA's books under the Apollo Extension Series, retaining the cachet and potentially the funding levels of the Apollo program. And NASA had some pretty lofty goals for these initial missions, and it all hinged on using an uprated spacecraft, namely the Command Module. A Block 2 Command Module was the one that went to the moon. The Block 3 would be for the Apollo Extension Series, and it would have some significant advances. One of the main experiments under the Apollo Extension Series was to be the Apollo Telescope. This would be a dedicated solar observatory that astronauts could use to make detailed observations of the sun from outside the Earth's atmosphere. There would also be a host of experiments on board, including biomedical questions, behavioral questions, questions concerning artificial gravity, living organisms in space, the behavior of liquids and gases in space, and astronaut observations and EVA development. The lunar module could also be used for other non-landing missions around the Earth and around the moon, and could start building the framework for a worldwide communications resource, and also just be used to fly packages of instruments. There was also some talk of using the lunar module as the anchor point for that Apollo telescope. Basically, the idea was to leverage the lunar module's extremely reliable propulsion system into these longer missions, even if the spacecraft itself was designed specifically just to land on the moon. Using the Block 3 Apollo Command Module with or without a lunar module or some kind of environment module added, NASA was looking at missions in Earth orbit lasting up to 6 months and missions in lunar orbit lasting up to 6 weeks. As the Apollo Extension System developed, it took on a new name, the Apollo Applications Program, and the emphasis of this program was clearly on science, not on the technology. But the Apollo Applications Program started coming under fire from Congress in 1967. The whole program was deemed too lofty in its goals and not organized enough in terms of its structure and management. And so as NASA started feeling the pressure of losing funding to Apollo, AAP became one of the earliest casualties. Only one goal from the whole Apollo Applications Program survived. While NASA was looking at these long-duration Earth orbital and lunar orbital missions, there was also growing interest in using an S-4B stage, the third stage of the Saturn V, as an orbital laboratory. This, of course, became the Skylab program. So if Apollo hadn't lost its funding, we would have 3 geology-heavy lunar landing missions and long-duration Earth and lunar orbital missions and Skylab. So at least we got Skylab. And of course, there are more things that NASA was looking at doing with its post-Apollo hardware. My friend Fraser Cain over at Universe Today looked at a couple of these proposals on the planetary side of things. So if you're curious to know what our future might have looked like with Apollo funding continued, be sure to check out his video, which is a companion to this piece. So what do you think of the Apollo future we never had? Which of these missions would you like to have seen the most? Let me know your thoughts in the comments below, and of course if you have other questions about Apollo, Apollo applications, or just anything old-timey spacey, leave all of that in the comments below as well, and of course things you would like to see covered in future episodes. Be sure to follow me on Twitter and Instagram for daily-ish vintage space-ish content, and with new videos going up every single week right here, be sure to subscribe so you never miss an episode.